In this video, I'll be going over how we graph sine and cosine functions. So first, let's look at the parent function for sine, and we can see it here. Now let's just go over the basic characteristics of a sine graph. For both sine and cosine, we talk about the period length, the amplitude, and then we'll go over any shifts, but we'll talk about that later when we look at some actual examples. So the period length for a sine graph is the length that the curve, the length that it takes for the curve to start repeating itself. So let's say I start here at the origin. The graph starts to repeat itself again right here, right? And so the length of that that distance is 2 pi. So we say that the period length is 2 pi here. Now, we could have started somewhere else. We could have started maybe down here at negative pi over 2. If I trace the curve, I start to repeat again at 3 pi over 2. And that distance, again, from here to here is still 2 pi. So the period length here is 2 pi for the parent function for the sine curve. The amplitude of a sine or cosine graph is the distance from the horizontal axis, which in this case is the x-axis. So that the distance from there to the maximum. So we say the amplitude is equal to 1. And it's the same distance from the horizontal to the minimum value. That's we're going to say the amplitude here is also equal to 1. So it's always symmetrical about the horizontal axis. Now, the parent function has a horizontal axis of x equals 0. But if we had any vertical shifts, the horizontal axis may be something else. Okay, and then the other key trait about a sine graph is where it hits the x-axis or the horizontal axis. Now the parent function hits at 0, at pi, at 2 pi, and we could continue on 3 pi, 4 pi, 5 pi, etc. And this corresponds to what happens on the unit circle. So if I look at the unit circle, let's try to draw a better circle here. Okay, so if I look at that unit circle, the sine value is 0. Well, remember, on the unit circle, the sine value is the y-coordinate. So what the y-coordinate is 0 here and here, and that occurs at 0, 0, or I'm sorry, 1, 0, and then at pi, 0. And then if I kept going around, the next coterminal angle would be, this is 0, 0. The next time around is going to be 2 pi, 0. So these values are equal to 0 if these are going to correspond to what we see on the unit circle. So if I draw a circle here, okay, and if I go around, well, remember the sine values are the y coordinates on the unit circle. So this coordinate right here is 1, 0. If I go around, this one is negative 1, 0. So notice both of those y values are 0. And those angles, well, the first angle is 0 radians, and then pi radians. If I go around again, I get to 2 pi radians. And then if I go around again, I get to 3 pi radians, and so on and so forth. So 4 pi radians is back to 1, 0, then 5 pi, and so on. So those values correspond to when the sine graph is 0. Similarly, this maximum value up here of 1, that corresponds to this value on the unit circle, which is 0, 1. And that angle is pi over 2. And then the minimum value down here corresponds to this value on the unit circle, which is 0, -1, and that angle is 3 pi over 2. So one way to think about a sine graph is what happens kind of when we unspool the unit circle. If we untwist it, what are all the coordinates graphed on the xy plane? Okay, now let's look at the cosine graph. Oh, before I move on, so in general, we want to say that the max and min values, it occurred at pi over 2 and then 3 pi over 2. Pi over 2 is 1/4 of the way in the period, and then 3 pi over 2 is 3/4 of the way. So we say that the max and min occur at quarter points within the period. And then the zeros, well, the zeros are at 0, at pi, and at 2 pi. Well, the 0 is at the beginning of the period, the middle, and the end. Okay, so those are the key things, the key points. All these 5 points that I've highlighted, those are the key points, and this indicates where those all occur. All right, now let's look at the cosine graph. Now what we notice, we can compare these, see if I can get both of these on the same. So what we notice here with the cosine graph is the maximum and the minimum are at the beginning, middle, and end. And then the 0 points are at the quarters. So it reverses itself from the sine graph. So for cosine, we're going to say the max and min, those are at the beginning, middle, and end. And then the zeros are at the quarter points. Okay, we still have an amplitude of 1 here. We still see that this distance right here is 1, and this distance is 1. The period length is still 2 pi. So things are similar but different between sine and cosine. And here are the steps we're going to do to go ahead and graph one of these functions. So we want to write the equation in standard form, and both of these are those equations in standard form, and we'll see how we can get to that. And what we notice is that we have an A value, B, C, and D, and that corresponds to all of the shifts, any sort of transformation that happens. So the A value corresponds to the amplitude, and that is, you can think of that like a vertical stretch. The period length is 2 pi divided by B, and any vertical and horizontal shift. So the vertical shift corresponds to D, and the horizontal shift corresponds to C. So if we can write the equation in the standard form, all of this information is readily available for us. The third step is to divide the period into 4 equal parts, and then we apply any horizontal shifts. We'll see that as an example. Step 4, determine the 5 key points. For a sine graph, it crosses the horizontal axis. Well, this is what we saw up here. It crosses the horizontal axis, or the zeros at the beginning, middle, and end. So beginning, middle, and end, and has a max and min values at the quarter points of the period. And then cosine is just reversed. The cosine graph crosses the horizontal at the 1/4 points and has max and min values at the beginning, middle, and end. Okay, so we apply any vertical shifts to the 5 key points. The new midline is y equals d, and we'll see that as an example. Then we sketch a smooth curve through the 5 points on this in one cycle, in one period of the graph. All right, so let's look at some examples of this. Follow the steps from above to graph one period for each of the following. Also find the domain and range. Okay, I'm going to write this down here. Y equals 2 sine of 4x plus 1. Okay, so let's go ahead and write this in the standard form. The standard form is going to be y equals a, b x minus c plus d. So y is equal to 2. Sorry, I forgot to put the sign in here. Let me fix that. Y equals a sine bx minus c plus d. There we go. I forgot the sine function. So for this equation, we're going to say y is equal to 2 sine. The b value here is 4. And then I have x minus 0. We don't have to put minus 0, but for this one I will. So now we can easily see that a is 2, b is 4, c is 0, and d should be 1 here. And that's d. Okay, so now let's go through and get all the information. So the period length is 2 pi over b. So this is 2 pi over 4, which is pi over 2. The amplitude is the absolute value of a. So that's absolute value of 2, which is 2. The horizontal shift, there's none, because that's the c value. And then the vertical shift is the d value, and that, because it's plus 1, we're going to say up 1. It's vital that you say whether this is up or down. Do not write this, because plus means something different if it's a horizontal shift and a vertical shift. So we always want to say left or right or up or down. So don't do this. Okay. All right. And then once we have our period length, what we do is we split that into 4 equal sections. So our period length is pi over 2. So we're going to put that in a number line, and we're going to split that into 4 equal sections. So 0 to pi over 2. So split that into quarters. So half of pi over 2, just multiply pi over 2 times 1/2. I get pi over 4. And then multiply that again by 1/2. I get pi over 8. And then to get this third one, what you're going to do is add pi over 8 plus pi over 4. Right? I have a half plus a quarter. That gives me the 3/4 mark. So pi over 4 is the same as 2 pi over 8. So this is 3 pi over 8. That third quarter point is usually the hard one for students to get. So, all right, once we have that, I'm going to go ahead, since there's no horizontal shifting, those values are what's going to appear on the vertical or the horizontal axis here. And I'm actually, let's see, I'll just do 2 grid marks for each section here. So this is pi over 8. This is pi over 4, 3 pi over 4, and pi over 2. Okay. And then the amplitude is 2, and I'm going to shift up 1. So I'm going to put a 1 here, and that is the new midline. So that is now the line that the graph is going to revolve around. And then from there, the amplitude is 2, so I'm going to go up 2 to 3, and I'm going to go down 2 to -1. And I'm going to move these. No, I don't want to move those tick marks. Let's see here. Okay, just so that's not interfering with the graph. Okay, and so what I'm going to do, this is a sine graph. Sine always hits at the beginning, the middle, and the end. And then the maximum value is at the quarter point, and then the minimum value is also at the 3/4 point. Okay, so I have the 5 key points, and then I'm just drawing a smooth curve in between these. So I've done one period length of this graph. And then it just keeps repeating itself as I go to the right and to the left. One thing to mention is that if the leading coefficient, if a was negative, the graph would have started by decreasing. It would have been like this. It would have been I would have had a vertical reflection. So that's something to pay attention for. All right, and then the last thing that this question is asking is find the domain and find the range. The domain here, well, this graph just continues all the way to the left and all the way to the right, so the domain is all real numbers. And then the range is, well, what's the greatest y value and the smallest y value? The smallest y value is -1. The greatest y value is 3. The graph goes through those values, so I'm going to include those in my interval.